Now that we've set up our environment for our project and also got cargo watch running, let's start with the actual contents of the course. And the first topic that we need to talk about are variables. In my opinion, at least, the way I usually put it is that variables are kind of, as you can see, are aliases to stuff or data. For instance, if I in real world say lasagna, you probably think of dinner. So dinner would then be the name of that data being lasagna. You would do the same thing in Rust, in that you would say lasagna is equal, or sorry, dinner is equal to lasagna. The format for creating a new variable in Rust is with the let keyword. So you would say let, as you can see in here, and then we can say name is foo. Okay, and you can see Rust Analyzer then jumps in and detects the data type of this variable. So you don't have to specify data types in Rust usually, but we will talk more about data types later. So the format is let, then you specify a space, name of your variable, and then an equal sign, and then the data of your variables. And you always end your statements in Rust with a semicolon, except for a few specific places that we'll talk about actually later. Now, in Rust, your variables use a snake casing convention, and snake case, as its name indicates, kind of like you're creating kind of like a snake by appending different words inside your variable names using an underscore. And the creation of that, you can see there's a document that specifies how naming convention works generally in Rust. But when it comes to variable names, you use snake case. So for instance, if you want to say first name, you don't say first name as a camel case. Instead, you say first underscore name. And then you can say John in here. Now, let's go to the terminal in here, and we can see that we have a cargo watch running. So if I then press Command S in here, you can see that we're getting some warnings from our Clippy in here. So if I then try to print this, you don't have to do this, but I'm just going to show you. We're going to print this person's name, which is first name. Let's print that. You can see we're getting hello John printed to the screen. But if I then change this and use camel case, then let's change this in here as well, first name. And you can see now we're getting a warning from Clippy saying variable name should have a snake name convention. So try to use snake naming convention for your variables in Rust. So in Rust, as you've now seen, lines of code end always with a semicolon. So keep that in mind. I say always, but it's not truly always. In a few cases in Rust, you don't end your statements with a semicolon. So you can see here, we said first name is John, and then we can say let last name is Doe, for instance. And you can see that the statements are separated with a semicolon, and the lines end with a semicolon, so to say. Now that we have the name, so let's change this to name. We can print that with the println command in here. You can see it's got a println and then an exclamation mark. I'm going to explain this a little bit later, but for now we're just going to say println, and we're going to write the name of the user to the console. So let's say your name is, and then we're going to use a format specifier in here, and this is also a little bit more complicated. There's a lot more to this format specifier, which uses the display trait. We haven't talked about traits yet, but just know that if you're printing a simple variable to the screen, you first use the println command in here, or function, and then you say your text, etc., etc., and then you specify the format of what you're actually going to print to the screen. In this case, we're printing a string. And then let's just go ahead in here and say comma, and then you specify the name in here and a semicolon to end it. So let's go to the terminal and see how that looks like here. And then we go to our terminal, and you can see what is printed to the screen is your name is John. So we're going to talk more about these things later, what traits are, but for now, know that we have a string slice in here, which is name, and also we're then printing that to the console, okay? Now, as you've seen in here, the Rust Analyzer is telling us that Rust has detected the data type of this variable to be a string slice. We'll talk about string slices later on as we get into pointers. But just know that for now, that in almost all cases, unless your statement is very complicated for Rust to understand, Rust is going to detect the data type of your variables for you automatically based on what you specify as the data of the variable. So in here, by saying that we have a double quotation marks, double quotes, and then the data double quote semicolon, Rust is understanding that this is a string slice. And you can also say, let's age, for instance, is 30. And then you can see age is automatically detected to be an integer or of 32 bits width. Good stuff. Now let's go ahead and in the next line in here, as you can see, we have let's name, and let's then change the value of this name, or at least try to do that. So I'm just going to say name is dough. Okay. And we're going to get an error in here from our analyzer. And you can see it says cannot assign twice to immutable variable name, cannot assign twice. Okay. Actually, that was like a repeat of what it had already said. So cannot assign twice to immutable variable name. So this message is self-contained and it is explaining exactly what the problem is. In Rust, if you've created a variable with the let syntax in here or the let keyword, you cannot change its contents. So we call that variable immutable. So the contents of this let variable cannot be changed. And what this really means is that you have now created a piece of data that is stored in the memory, and you're pointing to that data using the name variable, and the contents of that variable are immutable and are sealed now, so you cannot change that content. However, in Rust, there is something called shadowing, and we're going to talk about shadowing it later. And you can say in here, name is dough. So this syntax is completely fine in Rust, but it's not fine in many other languages because shadowing is not supported in many other languages. But we're going to talk about shadowing later. Okay, so just know that once you create a variable in Rust with let syntax, it is immutable and its contents cannot be changed. Now, mutability is the ability to change the data inside a variable, or the ability for a variable to have its contents changed after you've defined that variable. And the way to do that in Rust is with the let mut or let mut, as I like to call it. So if you want to be able to change this variable or the name variable, you can go in here and say, I want this name to be mutable. So you say let mut name is John. And then later on, you will be allowed to change this variable's data. So I can say is Jane now. Okay, so you can see the content that is printed to the screen at the end is your name is Jane. And we're getting quite a lot of warnings in here. This is the Rust analyzer telling us, hey, you stored something in this name and then you immediately change it, meaning that you're not using John and you're not using Doe quite correctly as well. So it's pretty much telling us you could as well just say name is Jane, and that would work exactly the same way. And also giving us a warning saying that, hey, you specified this is immutable and you're not changing it. So just remove mutable. And then it's going to be quiet. So Clippy and the Rust analyzer together are going to work really hard to ensure that you're writing good Rust code as well. Just keep that in mind. Okay. So that's how you would create a mutable variable, let mut. Okay. That's how you would create a variable whose contents can be changed. After doing that, you can go ahead and change the name. So you can say name is Jane in here, as you can see, and this is completely valid for Rust code as well. So in Rust, you can change a variable's contents, immutable variable's content, but not its type. So after you've defined that this name is Jane, you cannot go ahead and say, after you've defined that this variable's type is a string slice, you cannot specify that this name all of a sudden is containing an integer. So you're going to get an error in here telling you mismatched types expected, a string slice found integer. Okay, so let mut in Rust creates a mutable variable whose contents can be changed, but to the same data type. So if I go in here and say let's remove this print statement in here and say let mutable age is 20 and age is 30. This is completely fine Rust code, but you cannot go ahead and say age is hello all of a sudden. So this is also going to give you an error saying that, hey, I was expecting an integer, but you gave me a string slice, so that's not acceptable. All right. Now, what are data types? Data types are, as their name indicates, are types of data, types of values that you place inside your variables. So in here, you can see the Rust analyzer is quite correctly detecting that the data type for this age variable in here is an integer, 32 bits. So it's saying that it is actually a signed integer, meaning that you can put plus and minus values in here. So you can say in here, for instance, age is -20. And then that is completely fine Rust code as well. You can see in here, the data types is still I32. Okay, so data types are the type of information that you quite frankly put inside your variables. So there are various data types in Rust. Some are integers, some are strings, but let's just first talk about integers. Integer types can be specified using u or I prefixes. So in here, you can see we have I32, but you can also specify a variable of type U32. Now, the difference is that I are signed values, meaning that they can contain plus and minus values, but U are unsigned values, meaning that there's no plus or minus in there, it's only plus. So U is unsigned, meaning that only positive values, and I values are plus or minus. So you can also be explicit about your data types in Rust. So you can see in here, we're saying that age is I32, but if for some reason you want to specify the data type of age, you can go ahead and say, oh, this is an unsigned value of only 8 bits long. And now you will get an error telling you that, okay, if this is an unsigned value, you cannot put minus before it. So I'm just going to remove that. And then now all of a sudden, this is completely valid Rust code. Okay. Now, you can also, either you do this, or some developers prefer to, let's bring the label for that. Some developers in Rust actually prefer to specify the data type of their variables at the end of specifying that actual data. So instead of saying age is an unsigned value of 8 bits and equal to 20, you can actually say it's equal to 20 U8. And it's the exact same thing in here. So Rust basically then understands, okay, you have the value of 20, and then it's an unsigned 8-bit integer. Okay, so you can go ahead and do that as well. Now, Rust can almost always detect your data types for you, and it will actually fit them perfectly for the architecture of the current computer that you're compiling on, or the architecture that you will be compiling for. But sometimes you may wish to be specific about what data types you're using. And then you can go ahead and do that using the colon and then the data type format, as I showed you before. But in most cases, you don't have to do that. Now, integer literals can be very specific. As you can see, there are some examples in here. So if I say, for instance, population is, here you can see actually this is a suggestion from GitHub Copilot. You can see it's telling us that this is 62 million, and it is specified using underscores, which is separating every 3 digits in here. So you can remove these underscores, and this will be so fine. But you can also be specific and saying this is 62 millions by separating 3 digits from each other using an underscore. Okay, and I've also specified some more examples at the bottom of the screen. You can also specify hex values. So you can say, for instance, red is 0xFA. Okay, so this is fine. Or you can say let RGB is, you can see now, OX, for instance, like this. So you can also specify your data like this. So there are various ways of specifying your data. And to be honest with you, there is no point for me to go through all of these right now, because as you will get better and better at Rust, you will understand these data types as we, these data specifiers as we go on. I'm more of a believer of doing that rather than going through all of these at once right now. So just like you have integer values, you also have floating value supports in support in Rust, and a floating point. And floating point values are values that have decimal points in there. So for instance, a fraction. So you would specify those data types with F32 or F64, basically floating point 32 bits or floating point 64 bits. And if you, for instance, have, what can we specify as, so if we say distance in kilometers, okay, so let's see, it says 5 at the moment, and I can say 5.5. So you can see now the data type is specified to be F64. And I can go in here and say F32. You can see now the data type is changed to F32. Or I can go in here specifically say F32 as the data type, and that will work as well. So if you're going and using fractions, using these dots, then your data type is automatically going to be an F32 or F64 as in floating point values. Okay, good stuff. Now that we talked about that, let's also talk about operators. Just quickly, operators, as you may already know about them, are functions that do stuff to data, usually to one piece or two pieces of data, almost never to three pieces of data. So how they work is that, let's say distance 1 in here, distance 1, and then let's say distance 2, okay? Distance 2, and then let's say 6.2, and let's see if we can get a total distance from GitHub Copilot. You can see in here it's saying that this total distance is equal to distance 1 plus distance 2, and this plus in here is an operator. And what it is doing is that it's taking the data to its left-hand side and it's adding that to the data on its right-hand side. So this plus operator in this case is working with two pieces of information. So if in here you go ahead and say distance 2 again, let's create a distance 3 in here. So let's say distance 3 is equal to 10.2, and then we use that in here. Now, if you do that, you would be like, okay, but Vandal, you said that plus operator doesn't work with three pieces of data. So how is it working right now? The way it's working is using, it's basically finding the priority of these values and doing the operation one at a time. So it's first going from left to right, adding these two values together to end up with the result of distance 1 plus distance 2, and then taking the result of that and plussing it with distance 3 as a new function call to the plus operator. So you don't have to go, or we don't have to go too much into these details about it, but just know that there are some basic operators out there in Rust that you can use on your primary data types, such as integers and strings and floating point values, okay? Or even booleans. So these functions, these special functions are called operators, and you can also create your own operators. So that's quite short about operators, okay? Now, let's remove this code from here and let's talk about now variable shadowing. We saw an example of variable shadowing a little bit before, but I don't think we actually went so much into it. Now, Rust has quite a unique support for variables and how they interact with each other. And this feature is called variable shadowing. And that means that once you create a variable in a context, you can create the exact same variable, but specify another data for it and another data type. So many languages like Swift don't support this, for instance, that you can create a variable and then create the same variable again in the same context, but Rust has support for that. So let's have a look at that. So in here, if you say name is foo, you can go ahead and say let's name is bar. So this is a syntax that is completely valid syntax in Rust, but not in many other programming languages. So the fact that we specified the same variable name, but we specify another data for it is completely, it is called shadowing, and it's quite unique to Rust. So in here, you can also say 10 if you want to. But I suggest you never do that. You would never specify 10 as the data for a name. But this is just to show you that you can create a variable. Let's actually call it data. And then you can change not only its data, but you can also change the data type. So just because you're shadowing a variable data in this case, it doesn't mean that you have to specify the same data type, which is foo, which is a string. So I can say bar in here, or I can say 10. And create a floating value in here, 10 or 20.2. So the fact that we're recreating the same variable with the same name in Rust is called variable shadowing. Okay, so in Rust, we also have shadowing support in blocks. So if I say let data is foo, you can create a new block of code in here with this format with the curly brackets, and then you can recreate this data variable in here as well. So let's say in here we say let data is data dot toString. Okay, as you can see here. So you can see now we're basically using the previous variable's data or information to create our new variable with the same exact name. However, this new variable's data type is now a string. The previous data type for the data variable is a string slice. Okay, I understand this could be a little bit complicated to start with, but I think you get the basic idea of variable shadowing in Rust now. Now, just like we have variable support in Rust, we also have support for creating constants. Now, constants, as the name indicates, are variable or they're data whose value is constant throughout the execution of the entire application. So their value does not change, and it's not allowed at all to change. So they don't follow the same rules as variables. As its name says, they're constants. Okay, so constants should equate to a constant as well, meaning that a constant's value cannot be set to the value of a variable. Okay, so let's go ahead and actually create a simple constant in here. So let's say const, oops, actually the data at the bottom of the screen should actually say const. So I'm going to change that, const. Let's bring it back up. In here, we're going to say const, and we're going to say my age. And then we're going to say this is an unsigned 8-bit value, and let's say 22. Okay, so you can see now we've created our first constant. Now, constants, you can see in here, they should be uppercase, and they're using the snake case kind of convention by separating different words in the constant name using an underscore. So you wouldn't say my age. That's usually not a good naming for constant values. So let's go ahead and actually print this and see if Clippy can catch that for us. So you can see constant my age should have an uppercase name. So actually, yeah, Clippy is telling us that we should use uppercase. So let's say my age, and you can see now it is happy with the code that we've written in here. Okay, so that's really good. Now, constants should always have a default value, meaning that you can't create a constant like this and just expect everything to work, because you can see it says this constant doesn't have value or doesn't have a body that becomes an expression that evaluates to a value. So always specify value for your constants. So a variable can contain the value of a constant, but not the other way around in Rust. So in here, I can say let my age is my age, as you can see in here. Okay, so this is completely valid Rust code, but I can never in here say, let's say, I can never in here say this my age is equal to my age, which I've defined somewhere else as a variable. So this is not a valid Rust code. Okay, so your constants always have to evaluate to a constant value that you specify at compile time, and your variables can grab the value of a constant, but not the other way around in Rust. Now, let's move on to another way of containing variables and values in Rust, and that is called tuples. If you're coming from some other languages, such as Swift, you're probably already familiar with tuples. And tuples are also supported, for instance, in languages like Python and JavaScript. Some of the languages don't have support for tuples yet, such as Dart. If you're a Flutter developer, for instance, you may not know how tuples work or at all, or you may just not know how they work in Rust. So let's quickly talk about tuples, though I'm going to go a lot more into details about tuples in later chapter when we talk about collections, because tuples, in my eyes at least, are a kind of collections. Okay, now tuples are useful for storing multiple pieces of data that are somehow related to each other, usually, okay? Now, the way to create a tuple in Rust is just with parentheses. So if you can see in here, we say personal data is equal to, and then you create your tuple with parentheses. And then we say age is 22, for instance, and name is John. So you can see now this personal data variable has become a tuple as Rust Analyzer specifying in here, whose first piece of data is an integer of 32 bits long, a signed integer, and the second piece of data is actually a string slice. Now, the way to grab the data out of this tuple usually is by specifying the data, the variable names inside parentheses, and then equaling that to the tuple's variable name. So in here, you can say let. Oh, actually, I can see the GitHub Copilot is understanding the code that I want to actually write. So you can see this is how you create the tuple. So one more time, this is how it looks like. Parentheses, age, and name, and then close the parentheses, and you'd say is equal to personal data, which is your tuple name. So this is how you basically unpack the data inside a tuple, okay? Now, these pieces of information, as you can see in here with a column and then the data types, is something that we don't write, but a Rust analyzer is understanding the data types for us. There is a way to disable this. I actually tweeted about this a few days ago. If you're bothered by Rust Analyzer specifying the data types all the time, there is a way to disable it, and they're called inlay hints, I believe. But to be completely honest with you, I do not suggest that you disable these, at least not when you're getting started with Rust, because they serve a very specific purpose, very important to begin with, in that you will understand data types a lot better if you have these inlay hints, as Rust Analyzer calls them, to begin with. So you understand the data types a lot better. So in here, for instance, if I say age is actually a U8, you will see that you will get an error in here saying that, okay, actually, let's put a comma in there. So too much comma in here. And actually, let's read the error in here. Syntax error, expected comma, as you can see. So you cannot go ahead and actually change the data type in here, but you can change the data type of the actual value by specifying it in here. Oops. Say this is a U8, okay? And then it automatically changes when you unpack the data from the tuple later as well, okay? Once you have a tuple, you can also unpack data in it using the index of the data, which is 0-based. So if you say personal or let's age is, you can see it says personal data dot 0. And if you put a dot in here, let's see, you can see it understands that there are two components in this tuple. The one is at index of 0 with the data type of unsigned integer of 8 bits, you can see to the right-hand side. And the second component at the index of 1 is a string slice, okay? So if you say in here, let's name is that, that's also completely valid Rust code, okay? We can also iterate over tuples, but this is a topic that, as I mentioned before, we're going to discuss in a later chapter when we come to collections. Okay, great stuff. We've now learned the basics of variables, and throughout this course, we're going to basically create a lot of variables and work with variables quite a lot. So I think if you got the basics of how variables work in Rust in this chapter, then you should be good to go for the chapters that follow.